So moving on with mensuration. So these are composite shapes. We're skipping this and moving on to area and sectors. Okay, arc length and sector area. So before we continue, let's just get used with the formulas. Shape, area, perimeter. So if I say circle, what is the formula for circle?
Um,
Area,
Pi r square.
pi r square. And perimeter is
2 pi
2 pi r. So this is the radius and we use this formula. And when we talk about semicircle, this is half of the circle. Now what will be the area, Harris?
uh, area sir, it will be the
half
half of
pi
this.
Half of this. So pi r square over, when you have the complete circle, that is pi r square. When it is half of that, we are at pi r square by 2. And what about the perimeter?
Perimeter is the, it will be also be half. Okay.
Half of this. Ali, are you okay with this formula?
Yes, sir.
This is not complete. Plus 2r. How? Let me show you. When we are talking about complete circle, this starts here, let's say at A, and moves around the circle 360 degrees and come back at A. This is 2 pi r. But when we talk about half of the circle, let me make another circle, semicircle. So half of circle, this starts here, and this section is half of the boundary. But we do have two radiuses, 1 and 2. So outer boundary is half of that, that is pi r, 2 pi r by 2 plus 2 times radius. So the formula comes out to be pi r plus 2r. Or some may be interested to write pi r plus d, where d is the diameter. Is it clear?
Yes.
And when we
Yes.
talk about, let's say, the third shape, 1/4 of a circle, that is quadrant. So that's a quadrant. Area would be pi r square by 4. Fourth part of the circle. If I draw the circle completely and split it into equal 4, so that's pi r square over 4. And when we talk about the perimeter, now again, it starts at A, moves round till B. This is 1/4 of complete. So 2 pi r is complete divided by 4. But we do have two radiuses, 1 and 2, for perimeter of this shaded quadrant. Does it make sense?
Yes.
So pi r by 2
Yes, sir.
bar in simplified form. Now we talk about sector. So if I draw this sector, angle theta, before we move on to formulas, there are few names. Smaller would be known as minor sector. Larger would be known as major sector. Minor sector and major sector. Differentiated by angle when it is less than 180 or more than 180. So when we talk about the area, now area, let's say I'm talking about this minor, this shaded part. So area of this shaded sector or minor sector is theta out of 360 of the complete area. IR square is for complete, and this is theta angles out of 360. In the same way, when we talk about perimeter, that is basically arc length. This marked in red is the arc length, And what is the arc length? Completely it was 2 pi r. Full circle was 2 pi r. So this is theta out of 360 degrees into 2 pi r. So that is the red part, and this one in green are two radiuses. So plus 2r. Now we'll be dealing with this sector, whatever the angle is. This is radius, this is radius. Symbol for arc length is usually S. So area is equals to angle by 360 into pi r square. Perimeter is equals to arc length plus 2 radius, where perimeter is angle by 360 into 2 pi r plus 2r. So these are the two formulas we use and solve the shapes interchangeable. Sometime perimeter would be given and we'll be asked for the radius. Let's have a look at the exercise directly. Exercise 5.3, question number 1. Question 1 says arc AB subtended at angle theta. Keep looking at the diagram as well. Subtended at angle theta at the center of the circle radius r. Find the arc length and sector area when radius is 4 and angle is 30. So this is our case. This is capital A, capital B, angle is theta, radius is there. And we say that radius is 4 centimeters and theta is 30 degrees. And we need to find arc length and sector area. So for sector area, formula is pi r square, and this is theta out of 360 of pi r square. Angle is 30 out of 360 into pi, and radius is 4 squared. Now it will also depend, the degree of accuracy will depend on the demand of the question. So 30 by 360 is 1 by 12 into 16 pi. 16 by 12 is 4 by 3. If the question says in exact form, we will write this answer. But if they are asking for three significant figures or something, so into pi, I'm getting 4.19 centimeters square up to three significant figures or two decimal places. Any doubt?
No, sir.
No, sir. Okay.
For A part, we are now doing arc length. Arc length is angle out of 360 into 2 pi r, where angle is 330, 360 into 2 into pi, and r radius is 4. I'm using calculator straight away. 30 by 360 into 2 into pi into r is 2 by 3 pi, or 2.09 centimeters. This is arc length. What did we do? This is the complete circle. This was the center, and we found out only this length in blue. We didn't add two radiuses because he didn't ask about the perimeter of the sector. That was only the arc length. Now use your paper pencil and quickly solve and share question 1b.
This will be like a
The
sector.
radius is 10 centimeters and angle is 45 degrees. And you are more than welcome if you want to see the formula. In
Yes,
exams, you won't be given with these formulas.
yes, 1B. Okay, 1B, where 1B? Yes, it's to find the Yes, sir, I understand. Sir, 39.2 means 39.3.
Area is 39.3. Very good. Centimeter square.
Yes, centimeter square.
Arc length.
Oh, yes, also. What's the area? This was arc length. So to be, so arc length. Things we did wrong.
Ali, do we have the same answer?
Yes, sir.
And arc length?
And arc length, yes, right. And I'm telling. Take down. So it will be 7.85 centimeters.
0.85 centimeters. Ali,
Square.
are we getting the same answer?
1 second, sir.
Take your time.
Yes, sir. 7.5.
I'm coming to question number 2. In question 2 and 3, find the total area of the shape. So we're given with few lengths. OA is 4, and that's a radius. OB is 3. OC is 5. OB is 3.
Yes, so this I can do.
Okay, OB and OD are equal.
Yeah.
And okay, 1, 2, 3, 4. So basically we have 4 different sectors, and we add areas of these 4 sectors. I'm working with you on this. So question number 2, I'm starting with this first one in the order as it is given. So when I look at that angle, that sector, I'm looking at angle by 360 into pi r square. Then I'm looking at the second one with OB as radius. This is angle by 360 into pi, and the radius is 3 squared. Then I'm looking at the third one with radius OC, which is 5, angle by 360 into pi r squared. Then I'm looking at the fourth one, and the angle is missing. So I'll solve for the angle first. That is 360 minus all of these 3, which
Yes.
is 60 plus 45 plus 120. It leaves me with 225.
Yeah.
So 360 minus 225, I'm getting 135. So the remaining one is angle by 360 into pi, and radius is again 3 r squared. We're done with the basic step. Now just the simplification. So 60 by 360 into 2 squared. That was 2. That was 2, yes. Into 2 square, I'm getting 2 by 3 pi. Then 120 by 360 into 9, I'm getting 3 pi. 45 divided by 360 into 25 is 25 by 8 pi. 135 divided by 360 into 9 is 27 by 8 pi. I have this habit to keep things mostly in exact form. 2 by 3 plus 3. In exam, it will entirely depend on the demand of the examiner and question. 25 by 8 plus 27 by 8 gives me 61 by 6 pi. And into shift pi, and in decimals, this is 31.9 centimeter square. Any doubt?
No.
Okay, give a quick try to question number 3.
Option 3. Yes.
And meanwhile, I'm doing it with you directly on YouTube.
Three. And then we have the end.
Almost done.
Yes, sir, I'm on the last one. 60, 30. Okay. Yeah, heard those. Yes. Mhm. So I think so it's 31.24 or 31.24, yes.
Yes, 31.24
24
centimeter
centimeters
square.
square also.
Degree of accuracy would again depend on the question. Whenever we will attempt that exam, we will read the instructions on the first page. I think Ali is also done, but Ali is a little silent. Question number 2 says find the shaded areas.
Yes, we'll minus the what we'll do.
5 minutes.
Yes, we'll minus the major arc with the minor arc, I think so.
Very good. So when we are talking about areas, these shapes are quadrants. Okay, so we will subtract
Yes, sir.
larger quadrant and the smaller quadrant. So maybe we just look at these shapes. There is suppose like this. Outer radius is 5 and the inner radius is 4. Angle is 90 degrees. The shaded area is equals to angle by 360 into pi r square minus angle by 360 into pi r square. This capital and small letter has nothing to do with the logic, just to differentiate. Angle by 360 into pi 5 squared minus angle by 360 into pi 4 squared. by 5 is 90 divided by 360. 60 is 4 5 getting 9 by 4 5, which is approximately equal to 7.07 centimeter square up to 3 significant figures.
Yes.
Try this B part.
Okay, B part. So we'll take this one.
I don't want to spoil the mood about asking about the homework, the PDF file which I shared in WhatsApp group. But from today, we're going to take it seriously for the exam, okay?
Yes, sir. Yes, sir.
Yes. Yes, sir. So I've got the answer.
What is your answer?
So for part B, I got 19.5.
19.5. Aris, do we have the same answer?
Yes, sir. I'm checking. I'm doing. I mean, I'm. Yes, okay. Yes, sir. We're getting same answer. 19.5.
Very good. Question number 5 says in the diagram, the arc, what's the diagram? Okay. In the diagram, the arc length is L and the sector area is capital A. Find the angle when radius is 5 and arc length is 7.5. This is the question which I was looking for. Okay, 5A, we have this shape. Angle is theta, radius is r, area is capital A, and arc length is marked with letter L. And I have to find theta, r is given, and arc length is given. So when arc length is given, I'm going for that formula. Arc length is angle by 360 into 2 pi r. Now you just plug in the given values. Arc length given is 7.5 and radius is given 5 where theta is unknown. That is 7.5 angle unknown by 360 into 2 pi and radius is 5. For the first step, I'm going to keep it in exact form 7.5 times 360 and all of this is coming here, that is 10 pi is equals to angle. Angle is 7.5 times 360, that gives me 2700 by 10 pi to 70 by pi degrees and divided by pi, I get 85.9 degrees. Clear?
Yes.
Yes, sir. Yes,
Try
sir.
part. Question 5b.
Okay.
Yes, sir. Sir, I got 57.3.
57.3. That is correct.
Yes, sir.
Aris?
So I got the same 57.3 centimeters.
Area is angle by 360 into pi r
Yes.
square. Area is given, angle is unknown, 360. Radius is given, which is 2. So this goes there, 2 into 360, and this comes at the denominator. Theta is equals to 57.3 degrees. That is one decimal place. Angles are usually written in one decimal place.
Yes, sir.
Okay.
Question number 6. I'm deliberately leaving one part in each question for a normal practice, and I will share some practice questions apart from the book from a different resource. The length of minor arc AB of circle center O is 2 pi. So we are talking about a circle and we have one major arc, one minor arc. This is our minor arc, and the length of the minor arc of arc AB of circle center O is 2 pi. This is 2 pi, that is A, this is B, and the length of the major arc is 22 pi. Okay, so all the way this is 22 pi. Find the radius of the circle and compute angle AOB. So if I just look at this, may I say the circumference is equal to 24 pi?
Yes.
22 pi
So
plus 2
Yes,
pi
sir.
is
so 2 pi r. Reduce.
right. 2 pi r is going to be 24 pi.
Yes.
Now we can solve for the only unknown, that is radius.
20, 12,
24 by 2,
12
12, and units would be centimeters.
centimeters. Yes.
So 6a, 6b,
6
say acute angle AOB. Now
Yes.
we already know the radius, which is 12 centimeters, and we can
Okay.
find this angle. We have the arc length, we have the radius, so we are going for the formula arc length. Arc length is equals to angle by 360 times 2 pi r, where arc length is 2 pi, angle is unknown by 360 into 2 pi, and radius just came out to be 12. I can cancel out this pi with pi, 2 with 2. So I'm left with 1 is equals to angle by 360 into 12. This goes there, 360 by 12 is equals to theta. Theta equals 12, 3 times is 36, so 30 degrees. Any doubt?
No, sir.
No, sir.
Okay. Was this included, chords and circles,
Yes.
Yes, sir.
in our syllabus? No, like you read that at school, but is it in your exam?
Just my, my,
And are your schools functional nowadays?
no, sir.
You,
So it's arc length and sector area only.
okay. If you're going to school, you can also like confirm this. No doubt we will do it, but we should not focus on the extra part
Yes.
for exam. Question 7 says the length of the minor arc and major arc of the circle are 5.2 and this. So let me say minor arc by small l, that is 5.2 centimeters, and major arc represented by capital L, that is 19.8 centimeters. Find the radius. So again, circumference would be smaller arc, minor arc plus major arc is 5.2 plus 19.8. 2 goes there, 20, 25 centimeters. Circumference is equals to 2 pi r. 25 is equals to 2 pi r. So radius is equals to 25 by 2 pi in exact form, or 25 by 2 into shift pi is 3.98 centimeters. B part says the angle subtended at the center by the minor arc. So this was exactly the same as question 6.
Yes.
Yes, sir.
B part of question 7 is angle by minor arc, and minor arc is 5.2. Arc length is equals to angle by 360 into 2 pi r, that is 5.2. Angle is unknown by 360 into 2 pi, and radius is 3.98. I'm writing 25 by 2 pi, any issue if I choose this.
No. No.
I just got the idea that we can eliminate it, or maybe we'll get an exact answer. Into 360 by
Yes,
25
sir.
is equals to theta, making theta the subject. So 5.2 times 360 divided by 25, and I'm getting theta is equals to 74.88 degrees exact. And if the demand of question is to write in one decimal place, which is always the case, so one decimal place, this is our angle. Try question number 8.
Number 8.
Is it readable?
Yes.
Yes, sir.
Calculate, okay.
And to be sweet in 1 second. Which 1 minute? And and um, um, I did.
Is A part done?
Sir, I'm almost done. I'm doing, but I don't. Sir, but I don't want to understand. Sir. 5, 10, just wait some.
Uh,
Yes, Ali?
Sir, I got for question 8, I got 30
Very good.
A part. Okay.
Haris, what did you get for A part?
So I'm still trying to do, but I don't understand what to do. 110.5. Can you explain A part once again?
Okay. It says a wheel of radius 10 centimeters is turning at a rate of 5 revolutions per minute. So 5 complete circles in 1 minute. Haris, would that mean that it is taking 12 seconds for one revolution? Because
Um,
it was taking 60 seconds to turn 5 times.
yes,
Yes.
okay.
5 revolutions per minute. So that means 12 seconds for one revolution.
Yes.
And if in 12 seconds it is completing that circle, that means it is completing 360 degrees in 12 seconds. We just divide with that and we got 30 degrees per second.
Okay.
Other way of writing the same question would have been 5 revolutions in 60 seconds, just like unitary method. So one revolution would be x. When we cross multiply, 5x is equals to 60. X is equals to 60 by 5. X is equals to 12 seconds. One thing. And then I can write that in 12 seconds it is making 360 degrees. So in 1 second that would make x degrees or y degrees. I'm just using a different variable. So 12y is equals to 360. Y is equals to 360 by 12. Simple unitary method, which gives me 30 degrees per second.
Okay.
That was A part. And B part clearly says the distance moved by the point on the rim in 2 seconds.
Sure.
So we know 1 second shows 30 degrees and 2 seconds. That is a very simple question. So we don't need to go in detail. We can directly write 60 degrees. So the wheel is turning 60 degrees in 2 seconds. The point is moving from
Yeah.
position this to
60.
position this.
Yes, sir.
Yes, sir.
We find
Yes.
this arc length. Arc length is angle by 360 into 2 pi r. Angle covered is 60 in 2 seconds. 360 into 2 pi and radius is given as 10. So there we go with our calculator. 60
So
by 360 into 2 into 10 gives me 10 by 3 pi.
yes, fine. So 10.47 or 10.5.
10.47 or
Yes,
7.
sir.
10.47.
was that centimeters? Yes, centimeters.